Okay, guys, so today we're going to be reflecting across a coordinate plane. So at the top of your graph paper, you're going to write reflections on a coordinate plane. Let's go ahead and write that down now, please. I'm then going to take my ruler that should be at my desk. If you don't have a ruler at your desk, look around. There should be some either on the floor or near you. If not, come see Miss Neville. Look around, Miguel. There's one in front of him. All right, so what we're looking at here, look around for a ruler. I'm going to create my 4 coordinate planes. You want to remember that our horizontal axis that goes from west to east is called our x-axis. Our vertical axis that goes from north to south is our y-axis. Can you label that just like Miss Neville has? We also want to label our 0. Miss Neville did hers tiny. And instead of doing our intervals or our numbers by 2s like we did yesterday, or by 1s like we've done in the past, today we're going to label them by 3s, okay? So I'm going to count 3 blocks and put a 3. 3 more blocks, 6, 9, 12, 15, 18, 21. Just the multiples of 3. I'm going to zoom in a bit so we can all see that. Remember, we're going up in the sky when we're writing on the upper part of our y-axis. So will those be positive integers or negative integers? You can say it out loud, guys. Positive. Very good. Okay, so we're going to write 3, 6, 9, 12, 15. Now I'm going to the left of the 0. And we want to remember this is just a number line. That's all it is. So when we go to the left of the 0, our numbers become negative. Okay? Counting 3. Now, Miss Neville's using a marker so you can see this, but I would highly suggest that you use a pencil. Just in case we make some mistakes, we're able to erase it. Let's go ahead and get the rest of our axes labeled. All right, so we should have our coordinate plane correctly labeled, okay? Together, let's make sure we remind ourselves of the 4 quadrants here. What quadrant is this, class? 1. This quadrant? 2. This quadrant? 3. Yeah, I'm going to write that down here. And make sure we're using those Roman numerals. We want to be really familiar with them. Okay? So today we're going to be learning about how to make a reflection or a flip on either from the y-axis or flip from the x-axis. When you think about the word reflection, you think about a mirror, right? I'm looking on the opposite side of myself. So when we're looking at a reflection, and we want to look at our notes now, guys. Let's pull out that notebook paper that you should have out. At the top, we're going to write the same thing we wrote. Much better. We're going to write the same thing we wrote at the top of our coordinate plane, reflections on a coordinate plane. Okay. And I want us to make sure we understand when Ms. Neville says reflections, I'm literally talking about a flip. We can flip or reflect over the x-axis and we can flip. Notice how Ms. Neville's skipping some space. And we can make a flip over the y-axis. Well, what does that look like? Let's take some time to write this down, and then we're going to talk about what it means or what it looks like to flip across either one of these axes. So I want us to draw a small coordinate plane, not a huge one. You don't have to worry about using that ruler, but I want to make sure we understand what's happening. When Ms. Neville says to flip over the x-axis, we want to remind ourselves that that horizontal axis that goes from west to east, that is our x-axis. Ms. Neville even labeled it. You should too. So when we flip over that x-axis, our original point may be, our original point may be actually here in quadrant 1, but when we flip over our x-axis, it's going to end up in quadrant 4. In quadrant 4, okay? If I'm flipping a point from 2, where will it end up over the x-axis? Quadrant 3. Very good. So we want to understand that when we're flipping over that axis, we're going to see a change in that address or that ordered pair. And that's what we're going to be experimenting with today. We want to remember that our objective for today, if you want to look on the board, that means you, find and plot reflections of ordered pairs across, thank you, I couldn't see it because of the glare, the X and Y axis. So that's what we're going to be looking at here today. So what would it look like? We're drawing another small one. If I were to reflect a point across the y-axis, well, remember that y-axis is our vertical axis. I'm going to label it Y. You should too. I'm going to move this up for us. And if I'm flipping over my y-axis, yes, if I'm reflecting over my y-axis, it's going to end up over here, okay? The original point was there. It's going to flip over here. Go ahead and take some time to write that down for me. And then we're going to have a star statement here that we don't want to forget. Reflections keep, and underline this one, highlight it if you have a highlighter. Reflections keep the same distance. And that'll make more sense to you in a second when we move into our guided practice. Reflections keep the same distance. Take some time to finish writing this down. So now let's move right into our guided practice here. And I want us to plot our first point in quadrant 1. So let's plot our first point at 12, 15. Where 12 and 15 meet. That's where I'm plotting my first point. I'll zoom in so you can be sure to see that. 12 on my x-axis, 15 on my y-axis. And I'm going to label it 12, 15. You should too. What we're going to do today is flip that 12, reflect that ordered pair, this dot. I'm going to flip it over my x-axis. Remember, when we're flipping it, we're just flipping it over on the other, in the other quadrant, quadrant 4 in this case. And then we're going to flip it over our y-axis. So I want to make sure you have that point plotted. And let's first flip this over our x-axis. Now, when we're flipping it over our x-axis, I want you to pay attention closely here. When we're flipping this over our x-axis, how many points am I up from the line? 12. Oh, I'm sorry, 15. You notice I'm 15 up from the line? Yeah, I'm 15 up. So I got to go the same distance the opposite way. Yep, 15 down. So what that means is, I'll zoom that out a minute. I'm going to stay at 12. I'm not moving from 12, but I'm going to flip it across that x-axis. So I'm going to go 12, negative 15. Okay, it's been reflected. I hope you can see that. Over the x-axis. I'll move that up for you. Possibly zoom that out a bit. Oh, goodness. Okay. So it was positive 12, positive 15, which makes sense because we're in quadrant 1. But now we've reflected it into quadrant 4. So what is our new address here, Kendall? 12, negative 15. So do you notice something here? When I flip over the x-axis, does the x coordinate change? No. Which one changes? The y. And it changes to the the opposite. Very good, Fifth. Very good. Now, we're going to flip over our y-axis. Now we're going to flip over our y-axis. Once again, pay very close attention to what we do here. When we flip over this y-axis, perfect. I'm going to stay at 15. That's the axis I'm flipping over. And I'm going to move 12 to the opposite side of my number line. So, stay up here at 15, and I'm going to find negative 12. Because after all, negative 12 is the opposite of positive 12. Wouldn't you agree? Yeah. So our new address here is negative 12, 15. That's our new address here when we reflect over the y-axis. Now, what did you notice here? Tristan? We did. And because we did, what changed? Elian? Did the 15 change? No. It stayed the same. So I'm glad we're seeing that pattern here. Hint, hint, hint. If you're able to master that pattern, you got this. If you're able to just remember what's going to change when I flip over whichever axis, it's going to be perfect. I'm not done with you yet. We're not going to start practicing for grades or anything because we're still learning here. Okay? So let's move back to our notebook paper. So in our notes here, we're going to create a box where we're able to see that pattern. You're going to create a chart Doesn't have to be huge. We're back on our notebook paper. I'm going to have 3 columns here. And one of those columns, you'll notice, is more skinny than the other 2. And we're going to have 4 rows here. Here, I'm going to write X, Y. You'll see Y in a second. I'm going to zoom in so we can see it. Here, I'm going to say reflect X. That means reflect over the X. And here, I'm going to say reflect over the Y axis. And we're going to play with 3 different ordered pairs today. We're going to graph with 3 different ordered pairs today on our coordinate plane. The first one we're going to do is -18, 9. The second one we're going to play with is 3, -9. And the last one we'll experiment with today is 21, 21. I'm going to read those to you again because it may be a little bit smushed. That first ordered pair is -18, 9. The second ordered pair is 3, -9. And my last ordered pair is 21, 21. Go ahead and have those written down. And we're going to move back to our coordinate plane. That's why we have both of these papers out on our desk today, because we're shifting from one to the other. So we're now looking at our coordinate plane. And remember, the first one we're going to graph here is -18, 9. So -18, we're moving all the way to the left on our negative side of our x-axis. And am I going up or down with 9? Up. That's a positive number. So my new point will be where those 2 numbers meet. And as always, we're going to list what that is. I'll move my hand in a second. -18, 9. This is our original. Let's first reflect it over our x-axis. Let's talk about what we noticed. When I flip over my x-axis, which number will change? The y coordinate? Let's see if that's true. Let's see if Miss Paisley's correct. Okay? So we're flipping over our x-axis here. So when we flip over, I'm going to stay at 18. But instead of going up 9, I'm going down 9. So I'm going to find -18, -9. Was Miss Paisley correct, y'all? She absolutely was. Now, we're going to reflect -18, 9 over our y-axis. So what's going to change this time, do you predict? The x, yep. I'm not going to change where I am on that 9. I'm flipping over that 9. But now instead of a negative 18, I'm going to use a positive 18. So where the two meet, 18, positive 9. Let's add this to our chart. When I reflected over my x-axis, what was my new number? Or my new ordered pair? Negative 18, negative 9. When I reflected over my y-axis, what was my new ordered pair? Positive 18, positive 9. Now let's write this down in our notes because you're going to do these next two on your own. Okay? So let's write this down in our notes, the pattern that we see. Two star statements. When I reflect over my x-axis, what changes? When I reflect over my x-axis, what changes? The y-coordinate becomes the opposite, and my x-coordinate is the, say it, same. The x-coordinate stays the same when I reflect over that x-axis. So the opposite is true when I reflect over my y-axis. What does our chart show us? When we reflect over our y-axis, what changes? The x-coordinate changes, and what stays the same? The y. The y-coordinate stays the same. I'll move that up for you. Zoom it in a bit for you. And our x-coordinate is our opposite. Now you keep hearing Miss Neville say x-coordinate. What in the world is she talking about? What does that mean? Gage? Yeah, the address of where it's located on that coordinate plane. There you go, guys. So when I say x coordinate and y coordinate, I'm talking about this. This is my x coordinate. That's where it will be on the x-axis of a coordinate plane. And this is my y coordinate, where it will be on the y-axis of a coordinate plane. -3, 3, -9 reflected over the x-axis. Tell me again, according to our notes, what's going to change? The y into the opposite, and the 3, the x-coordinate, stays the same. If I reflect this point over my y-axis, what would it be? -3, -9. -3. Oh, hold up. It'd be a +3, wouldn't it? +3, +9. What? It is a -9. Got it. Yes. The y coordinate stays the same, sweet girl. What is the y coordinate currently? So it stays the same when you reflect it over the y. The 3 is what changes. So it should have been a -3, -9. Whew. What about 21? 21. What would it be when I reflected over that x? +21, -21. What about when I reflected over the y? -21, +21. It's a bit confusing, but I promise it gets easier as we go on.